All right, so we're going to do PFD day 2. All right, so if the denominator contains a nonlinear factor, that is irreducible over the reals, then you must allow your numerator to be ax plus b. Okay, so far what's happened is when we have factored the denominators that we've been given, we've had all linear pieces, okay? And so we have made our numerators just one single variable, a, b, c, whatever down the line, okay? Now what's going to happen is that that's not always the case, because we know when we factor, we don't always get a linear factor. So if we get something like x squared plus 1, this is something that's irreducible over the reals, right? It doesn't factor unless you factor it into an imaginary solution, okay? So that doesn't count here. When that happens, you have to use this numerator, ax plus b, okay? So that's why this gets a little bit more complicated. Okay, so we're just going to look at an example of this. So I have 2x squared plus x plus 8 over x squared plus 4 squared. Okay, so looking at this, x squared plus 4 squared. First of all, this x squared plus 4, everybody agree that it's nonlinear and that it's irreducible over the reals. You cannot factor this any further, right? So that means that we're going to have a denominator of ax plus b. So the first piece would be ax plus b over x squared plus 4. But that's only my first one. What's my second one? What does it need to go under? X squared plus 4 squared. And is that reducible over the reals? No. So then that means I have to have another numerator that looks like this. So now introducing c and d. So now I'm going to have cx plus d on this one. Okay, so still thinking along those same lines, what does this factor to? Do I have every piece that I need? And now we do the same thing. We clear the denominators. So do you agree I should multiply by x squared plus 4 squared and it will clear what I need it to clear? It's just going to get messy. Okay? So I'm going to multiply by x squared plus 4 squared. When I do that, I'm left with 2x squared plus x plus 8 equals ax plus b in parentheses, because that has to get multiplied by x squared plus 4. Right? These are two quantities. We have to multiply them together. Plus, luckily here, the entire denominator cancels. So cx plus d. Okay, so now once I get here, this is a situation where I'm like, all right, well, I'm not going to be choosing any values, okay, because there's a lot going on right here. So this is the perfect opportunity to use the coefficient matchup, okay? So that means the next thing I have to do is I have to expand. So that's what I'm going to do next. So I have 2x squared plus x plus 8 equals, and then you just have to FOIL this piece out. So ax cubed plus 4ax plus bx squared plus 4b plus cx plus d. Okay, so far so good? And now we want to line everything up. So I'm noticing that I have an x cubed, but I don't have an x cubed over here. So I need to add that placeholder. So I have 0x cubed plus 2x squared plus x plus 8 equals. I only have one x cubed term, so that's just ax cubed. Now going down the line, I notice that I have an x squared, so plus bx squared. I have a 4ax and a cx. So that's going to give me plus 4a plus c times x. And then my constant is going to be this 4b and d. So plus, and I'm going to put that in parentheses because that entire thing is my constant. And now I'm going to match everything up. So I notice I have x cubed and x cubed, so that means that 0 equals a. That piece is easy, right? Then I'm going to match up my x squared, so I have 2 equals b. I'm matching the x squared with the x squared. Their coefficients have to be equal. There's nothing really to write out. So I have this x squared and this x squared. You just take those coefficients and you set those equal. Okay, so now remember that in front of this x I have a 1. Okay, so this 1x and this 4a plus c times x have to go together. So I set those equal. Now you can kind of solve this one right now, can't you? Because you know a. A is 0. So here I can plug in a 0 for A. So that means that C is 1. Okay, then I have my constant. So here I'm going to match those up. So I have 8 equals 4b plus d. But again, I'm going back to that previous information that I found, and I notice that I know that b is 2. So I'm going to plug in a 2 for b. Subtract over that 8 and you get d equals 0. Are there any questions on how I found a, b, c, and d? Okay, so now I'm ready to plug it in. So now a goes where a goes and so on. Okay, so I have 0x plus 2 over x squared plus 4 plus 1x plus 0, bless you, over x squared plus 4 squared. All I'm doing is plugging a, b, c, and d back into my original setup. Well, what happens with these zeros? We've got to simplify that, right? So you're just going to end up with 2 over x squared plus 4 plus x over x squared plus 4 squared. And just like that, you're done. Questions? Yeah. You don't. You can set this equal to that 2x squared plus x plus 8 over x squared plus 4 squared, but you don't have to. Yep, doesn't matter. Also, if you want to check your work, right, what could you do? Couldn't you work with this piece, get a common denominator, and make sure it matched, right? That's all we've done is we've gone backwards and we found out what it was before we combined it. Okay? Yes?
I'm just really confused on how, like, the first step when you find the denominators, how did you get those?
So this is just like if I had x squared. I would have x and x squared. So this time, this x squared plus 4, it's not factorable. So that is just the denominator that I have. And then I got to go down the line. So I have to the first power and then to the second power. Okay? Good on this one? Okay. There is one more type. Okay. If you have an improper rational expression, okay, divide using long division. first, then do PFD with the remainder. You have to use long division. You cannot use synthetic division in this case. So, we're going to try one. So we have x cubed minus x plus 3 over x squared plus x minus 2. Okay, so looking at this right now, do you understand what I'm telling you when I say that it's an improper rational expression? Think about what it means to be an improper fraction, just in general. What does that look like? Doesn't that look like the numerator being greater than the denominator? Okay, now think about how that translates into this situation. What do you notice about the degree in the numerator? It's bigger than in the denominator, so that makes this improper. Now, if you go back to the last example we did, we had an x squared over an x to the fourth. It wasn't improper, right? All of the examples that we've done so far have not been improper. Their degrees in the numerator have been lower than in the denominator. When you have this situation, first of all, you have to recognize it, okay? So that's the first thing you should look for every time you do a PFD now, is look to see if it's improper. So, if the degree in the denominator is lower than in the numerator, then you have to do this process. And before you can even begin this problem, you have to use long division. So let's start there. So I have x squared plus x minus 2. And remember, we want that placeholder for the x squared term just to kind of keep everything lined up. Okay, and now I'm going to do long division. So how do I take x squared and change it to x cubed? Multiply it by x. So now I have to distribute that all the way through. So I get x cubed plus x squared minus 2x. Remember that all of these are subtracting, right? So you have to change the sign of each one of them. So I'm subtracting this, and adding this. Alright, so that's going to give me a negative x squared plus x plus 3. In order to take x squared and change it to a negative x squared, we have to multiply by a negative 1. So I'm going to subtract a 1, and then I have to distribute. So I have a negative x squared minus x plus 2. Every single one of those is getting subtracted, so I go through and I change all of the signs. This is going to take me to 2x plus 1. Okay, now, I can't take this x squared and change it to 2x. So this becomes my remainder. So this piece right here is incredibly important to us. Alright, so our remainder becomes our numerator. So now I'm ready to start the PFD process. So I use my numerator. I want you to maybe highlight or circle or star this piece right here, because what happens is it just kind of drops off the grid and you forget about it. And it's essential in our answer because it's part of our answer. Okay? So now let's set up our PFD. So I take this numerator, this 2x plus 1, okay, and this becomes this new numerator. So this goes over our x squared plus x minus 2. Okay, and now we start PFD. So now I'm back to square one. I have a proper fraction now. I'm going to try to factor the denominator. So does this factor? It does, to x plus 2 times x minus 1, right? So now those become my pieces. These pieces are linear, yes? They're x plus 2 and x minus 1, which means I can just have those denominators like I had on Friday, where I have a and b. So this is going to be equal to a over x plus 2 plus b over x minus 1. And now I start PFD. So now I have my setup. What's the next thing I need to do? Yep, clear that denominator. So I'm going to multiply this all by x plus 2 and x minus 1. So I have left 2x plus 1 equals a times x minus 1 plus b times x plus 2. So this is a perfect situation where you can just choose those values for x in order to cancel out your variables. So what value should I choose for x? 1 and negative 2. So I'm going to plug both of those in. I'm really tight on space, so I'm showing minimal work here. So if I plug in a 1, I have a 3. The a term's going to cancel, and I'll be left with 3b. So that means that b equals 1. If I plug in a negative 2, I have negative 3 here equals, let's see, negative 3a. That b term cancels. So now I have a equals 1 as well. So I plugged in 1, and I got 3 here. This canceled, and then 1 plus 2 gave me the 3b. Okay, so is everyone with me? I have a is 1, b is 1. Okay, so I got to plug that in to those pieces. So I have 1 over x plus 2 plus 1 over x minus 1. But this, if I was to add it together, would not give me this, would it? The only way I'm going to get there is if I tack on this original long division of x minus 1. So I have x minus 1 plus all of this. This is your answer. How you doing? Doing okay? Okay. Yes.
Does it matter if you put it in the front or the back?
I prefer it in the front. Okay, if you use long division, tack that right onto the front. It's not wrong if you put it at the end. It's just easier for me. Okay, what I want to do now is I'm going to give you 3 problems. Okay, and I only want you to set them up. So I want you to think about the setup that you would use, and then we're going to talk about it. Okay, and you can talk to your partner about it too. So if you can't get the setup right, there's no way you can get the problem right, right? The setup is essential. So we need to make sure we are comfortable with that. So let's call this example 3 and set up for PFD. Okay, so here are your 3 problems. So you are only setting these up. I don't want you to go through and solve them. Just set them up. I will give you a hint. On your setup for the improper fraction piece, you'll have to do long division before you can set it up properly. Okay? But everything else you should just be able to set up. An improper one? Think about the numerator's degree and the denominator's degree.
You know, so it wouldn't be x times x squared.
Right, but that's in the denominator. So you have an x to the first, right? You got to compare the numerator and the denominator. Okay, looks like we're making like real good progress here. Okay, so let's come back together. Those of you watching this video, I hope that you had fun on the pause. I don't know how to pause a video. Okay. It doesn't matter. They should have tried it on. You should try it on your own. Okay, so here, everybody agree that those pieces are factorable over the reals. Okay, so you should have started maybe with a over x plus b over x squared plus c over x minus 1 plus d over x minus 1 squared plus e over x minus 1 cubed. Do you have 5 pieces there? That would be intense, right? So this is why we're only setting this one up, okay? This is a situation where the coefficient matchup would probably work in your favor, okay? Now, B, did you notice that this x squared plus x plus 1 is not factorable? If you were to solve it, you would get imaginary solutions. So this is irreducible over the reals. It's a nonlinear term, so therefore you have to have that special numerator. Now, this x piece is linear, and it is factorable over the reals. So that means you can start that one with a over x plus bx plus c over x squared plus x plus 1. Did anyone have ax plus b over x plus cx plus d over this? That's okay too. It will work. You'll get a 0. Remember when we got zeros for a and d and they canceled on that one problem that we did? This one here, how those went away. The same situation would happen here if you used ax plus b and cx plus d. Okay? Just know that your problem will be harder to solve because you have more variables to solve for. Okay? But it is possible. But this is your best case scenario. This is your easiest option. On C, did you notice that this was an improper fraction and therefore you had to start with long division? So you should have started there. So I have x squared minus x minus 2 and x cubed plus 8x squared plus 0x minus 8. So let's see, we can multiply by x. We get x cubed minus x squared minus 2x. Change all those signs. I have a 9x squared plus 2x minus 8 left over. Here I can multiply by a plus 9. This is going to give me, let's see, 9x squared minus 9x minus 18. Change all the signs. You get 11x. What's that? Plus 10. And then this is your remainder. Okay? So your setup should be something like 11x plus 10 over this factors to x minus 2 times x plus 1. So then our pieces are going to be a over x minus 2 plus b over x plus 1. Correct? Okay, now, in terms of your answer, what is it going to look like? Your answer should be this x plus 9. Make yourself a note there. So your answer is going to be x plus 9 plus the a over x minus 2 plus the b over x plus 1. Whatever that a and b term are. Okay, yes?
I just have a question, like, if we're not even using the numerator, why do you have to solve for it? Could you replace it with a anyways?
So the numerator is how we got to this x plus 9 piece, which is essential to our answer. Okay, so that's where that gets factored in. All right? Okay, so you just know everything you need to know about PFD now. All right?